Okay, good evening, everyone. Welcome to another series of the volume, Meet the Engineers. Today we have the Electronics Engineer Talk event of series. So this is the fourth series in the event of series that we've been conducting for the past 1 year. I think we'll give a couple of minutes for the people who are joining. And we'll start in 2 minutes time, if that's okay. I'll take a sip of tea in the meantime. Right, that's 2 minutes past. I think we have our registered participants already online. Hello, everyone, and welcome to the fourth edition of the Meet the Engineer series of events. My name is Sham Kolorambate, and I'll be your host and panel chair for this evening. This event is an opportunity for young students, school leavers, and degree holders to understand more about engineering, what you've got in stock, both in terms of the work itself and in terms of a personal experience. And to talk about the personal experience, we have got two young professionals with us today, and we do call this series as Electronics Engineer Talk. Before we go into the series, we've got a few house rules. I'll quickly run through those. This event has been recorded, so those who are unable to attend this event live and those who are looking to revisit this event in future can access it. We will post it in our YouTube channel. The link to the CPD certificates for this event will be posted at the end of this event in the chat. We also got a survey for you to fill afterwards, our audiences, and this will be sent out to you via email. We do appreciate your comments, your constructive criticism, as it encourages us to do more professionally and more interesting events in the coming days. Please use the Q&A function that you can see in your Zoom screen, and keep your questions coming for our speakers for today. And this webinar will be approximate 45 minutes to 1 hour, and we will expect and will try to keep in time. This is the agenda we'll be going through for today. Our two young professionals today are Navdeep Mehay and Swetha Thayalsamy. Thank you very much, both of you, for joining, and welcome to Electronics Engineers Talk event. They will be speaking to us about their journey so far and their experiences as an engineer. With no particular event, a particular order. Navdeep will be going first, and then following with a Q&A session, and then we'll have Swetha speaking and a Q&A session. At the end, we'll have a few important announcements, and we will wrap the session at about 7 p.m. So without much further ado, I would like to welcome Navdeep, who's also one of my work colleagues. So I'm really proud to welcome him for this Meet the Engineer series, Volume 2 series for Electronics Engineers Talk. Over to you, Navdeep.
Thank you very much, Sham. Hello, everyone. I hope I could have actually seen you. I thought it might be more interactive, but I hope we can still engage. We can still keep the same engagement as if it wasn't real. So you heard my name, Navdeep Mehay. I work in UK Atomic Energy Authority. So this is if you haven't heard about it, we definitely ask you to search after this session. So what we're doing is we are doing research on the nuclear fusion energy. So as you already know, there is nuclear fission reactors. What we are working on is a low carbon and also safer power stations, which will be the future of the world. And we hope that in the second half of the century, we will have more of these power stations running and working and operational around the world. So it's a fusion energy. we have scientists, engineers, technologists all over from the world working on different tokamaks or different TORs or fusion machines. And I'm a machine control and protection group leader. So it's a group of engineers, technicians, electronics engineers, FPGA experts. We have CNI, control instrumentation, electrical, mechanical. I'm also a physicist in my team. So leading that group and working towards making this fusion a reality. And where I'm working, it's surrounded by all the physicists. So we have got all the sharpest mind around you. It gives me opportunity to learn more stuff. The talk says electronics, so that's what my graduation was. I graduated in India from National Institute of Technology in electronics and communication. Did 3 years as a lecturer to start my career. That was an experience because I think I learned on those 3 years way too much than I learned in 4 years when I was actually teaching. And then after that, jumped into power stations. So a coal-fired power station in India, worked there for 3 years. And in 2011, when I came to this country, again, working in power station, but then I moved to automotive industry. Similar control instrumentation, that has been my work since my degree. It has been more of the application of electronics rather than actually working on the electronics. But my aim, still the aim, has been to work in a core electronics like Intel or Texas Instruments or ST Microelectronics. These companies I would like to work for. Hopefully, there's still time. We'll see how it goes. But yeah, working in the UK Atomic Energy Authority for last almost 3 years, and it has been going good. But yeah, I'm keen to listen to you guys, answer your questions. If you have any doubts or anything, I would be happy to do that. Over to you, Sham.
All right, thank you very much, Navdeep. It was really a good introduction of where you actually came from. We've actually got the first question already from Joe Ryder. I think I'll start with that, and then as we move on, probably I'll also ask a few questions on the own experiences and journey up until now. So to start with, Joe has asked, what are the most common programming languages used in electronic engineering, and why are they useful?
Okay, so when you go into electronics, when you go into FPGAs, for example, it depends on the application. It depends on the environment you're working in. So previously, nowadays, if you go into, I was working in Jaguar Land Rover, which was a non-manufacturing test facility, and we had lots of electronics around us, but we are more of an end user perspective, more of an application. So we have the electronics working with different companies like HPM, MTS. So these are the companies who use the electronics, make those boards, and then provide to us. Which language do they use? So that's depending on what skill set do they have. But where I'm working at the moment, we have FPGAs. So Xilinx, we actually using their hardware and their language. But working across, I know we also have National Instrument, their kit as well. LabVIEW is a language they use. So it totally depend on different application and the skill set the company or the department may have.
All right, thank you very much, Navdeep, for that answer. Yeah, I think it was a really good question, in fact, to start with, that the programming languages actually used in the electronics engineering world, because we hear a lot of IT languages that's being used, the computer software languages, but not really in the area of an electronics. I think that question really was a good one, and thank you for your answer as well. I think fairly I knew where it was going towards, towards the LabVIEW and sort of stuff, but the other ones, which I have not even heard of, I think mostly the FPGAs, I wasn't really sure what that actually mean. If you could just give me a bit of a brief, I think, for our audiences as well, what that is all about.
Yeah, sure. So these are the free programmable gate arrays. So we can actually program, we can make it to our use. So similarly with National Instrument, they use boards. They have got FPGA based boards. So that's what they're actually doing.
Right.
What we do is, good thing about what we do, or it's amazing thing what we do, we actually got, we call it white rabbit switch. It's actually a switch which is used in CERN. Everyone heard about CERN? but we're using
Yeah.
a board, but of a different application. And then we have to reprogram it to make it work for us. Similarly, for our protection, our FPGAs, they are faster versions. So
Right.
honestly, you can say. So for our protection, so the machine that I'm working on, it's a 55 million pound machine. We have to make sure that we do protect it from abnormal use, because we do put high power into it for that. And it always goes for like 1 second. And when we say we are pulsing, it goes for 1 second, high power into it, and we have a plasma for 1 second, and that's it. So within the 1 second, we have to make sure that none of the coil, none of the machine's equipment is put to an abnormal load. For that, the protection circuit has to react even faster.
Even faster, okay.
So we have got fast timers which synchronize everything. That's again FPGA based. We also use Mitsubishi PLC, but in the protection system, we use the FPGAs again, like with Xilinx use. And then we have our expertise in-house who actually can program them, commission them, and the protection system is capable of reacting to any anomaly within 600 microseconds. So that's the speed that we actually need from the protection system, because it has to react within that 1 second, and we can't have it for too long. We can't have too much of reactive time.
Right.
So, yeah. So, and again, so these are the hardware that we use, and depending on different things, we apply on different applications.
We do on different applications, right? I think one related question to what I asked would be for our audiences, for the school leavers, for the audiences of this particular session. Is it something that you will only be able to learn if you're in industry, or would you be able to learn in your degrees, or is it between those times that you can learn these software, these applications? Where do you see all these learning coming in?
I think now, when I studied, it was a bit different to how things are happening these days. So these days, there's more of collaboration between the industry and the academia. I was doing, we had some placement, we had some training opportunities, but I wish there was a bit more. So at that time when I did, I wish that we had more look into the industry, how these things are applied. So my education was mainly theoretical. And then only when I was exposed to industry, that's when I was exposed, okay, this is how things happen. So whatever we have studied, that's, can say 10-15% of it, but how you apply into it, all the troubleshooting goes into, that's the key learning, which I enjoyed.
Right.
So, they definitely, I think these days, however, there is quite good collaboration. We do get projects. I mean, we have got scientists, we have got PhD students working with us from University of York, University of Durham, and so on. And they're working on these clever electronics, clever ways of measuring, clever ways of controlling the plasma. And that's when these things, you can actually see the application of this high-speed electronics into controlling the plasma. So plasma is like a jelly. So and you push it, you can see it wobbles around, and we're trying to control that within 1 second. So you can imagine that what accuracy, what control that we need. So yeah, you can learn in the theoretical in your books. However, if you do get the opportunity to go into the industry for a placement, for something, for any even a visit, I do highly recommend to go into these places.
Great, thank you so much for that. We've got another question from Lok Mani. Are you happy with the level of reuse as a fuel of radioactive byproducts of fusion in nuclear power stations? How is this sphere advancing in the UK?
So, good question. Let's go into. I mean, it's less to do with electronics, but however, it is a good question. So, I don't want to answer for fission because it's a totally different. It's a chain reaction, and what we're doing is a fusion. So in fusion, we do two hydrogen atoms that collide, goes into helium, and also we had loss of energy coming out of it. And good thing about fusion is that as long as you're supplying the fuel, which is hydrogen, or the heavy isotopes of hydrogen, which is deuterium and tritium, the reaction will carry on. As soon as you stop it, there won't be any reaction. So it's safe. But in fission, as we all know, it's a chain reaction. You have to do something to stop it. Otherwise, if you don't do it, it will carry on. But fusion, like I said, you have to feed the fuel to carry it on. As soon as you stop the fuel, it's gonna stop. So that's fusion. The radioactive products out of it, they're as compared to fission, they're very low. And also we are working on a technology so we can actually use that byproduct, which is tritium, back as a fuel. So that's what we are doing. So yes, so there will be some byproduct, but we are trying to use it. We are working on the technology. It's already there, trying to implement it so that we can reuse that byproduct, which is tritium, which is a heavy hydrogen, back into the reaction to give us more power for the electricity generation.
Right. And I think the follow-up question was how was this PR advancing in the UK? What do you think?
I mean, within UK, if again, I will answer for fusion. We have got this is where I'm working. It's a UK government's industry, UK government's own machine. Also, we are hosting the JET, which is called Joint European Torus. So which is like the name suggests, it's a joint European machine, but UK is hosting it. So we are getting the skill set within UK. In private sector, not far from where I work in Oxford, there's another company named Tokamak Energy. They're working on a similar front. And there's a company named Journal Fusion, which is in Canada. I had the privilege to actually go and see their plant in Canada. They actually bringing they're actually manufacturing or installing one of their kit into our site where we actually are working in Oxfordshire. So quite a lot of activity happening and good thing is it's happening in Oxford because we are trying to make a fusion hub. However, the first generation, the first power station, which will be connected to grid, will be not in Oxford, that's for sure, because we have 5 sites which are shortlisted, and one of those 5 is in Oxford. So it's spreading, and it's not just the fusion technology. What we are doing is within our organization, there is a fusion knowledge hub. So any learning that we're getting from these reactions, they're actually going towards helping the wider industry. So it's not just we working on the fusion, but what we're learning, we're trying to implement onto the wider industry. So yeah, it's advancing. 2040s is when we'll have a first power station. But again, there will be lots of electronics in it. Just watch the space. Or come and join us. That's the best thing you can do.
Long time, but not so long for a nuclear project, I would say. Yeah. Right. Thank you so much for that. Another question from Wayne Isaac. You mentioned entering the industry expanded your knowledge and skills. How did you go about learning and adding to these skills once outside of the learning structure of something like university?
So if I understand it, so
I think Isaac has actually asked you, like, how did you go about learning and adding to these skills that you have already learned, from the knowledge and the skills from the industry?
So my first job in industry was in a power station, and we used a Contronic 3 system from ABB, and it was all hardwired. It was you troubleshoot, you fault find on the cards. It's a whole. There wasn't any software programming in the units where I was working. So there were like 6 units, and 2 of them I was looking after for the electronics, for the control instrumentation side. So my experience has been learning on the job, which has been very good. I don't know if it's a good thing or bad thing, but whenever I took a job, the next person I was replacing, they were about to leave in like a few months. So those few months was accelerated learning for me, because if there's any fault, I think that's the best time you actually learn. I would be on site. It's daytime, nighttime, because power station, they're done 24 hours. So and after my induction, I took the opportunity. I want to work in maintenance rather than in operations, because that's where I saw myself working. And as a part of maintenance, you can be called anytime. So it could be night, it could be day, it could be 2 o'clock early in the morning, and you have to go there because you want to keep the power station running. So I would go there, fix a fault, and it might take maybe 50 minutes or half an hour extra for me to troubleshoot and fix it. than the person who's experienced, but that's the time I actually learned the most. So first learning was on the job. However, since I've been in this country, I have worked with IET, working on so I've done everything as my part of my job. But when I was doing my application for chartered engineer, I can remember that I was reflecting on all those learnings, which I was doing it, but it was just off my head. Okay, I've just done it. But when you put that on black and white on paper, that's when you reflect on what exactly have you done, and you do feel proud of it. And in 2017, so again, growing network, going to conferences, listening to people. I was listening to one of the guy who was the young professional in 2016 for the IEC, and so I approached him. I asked him. He gave me the guidance that there's an application that for the young professional for IEC you can apply. So I was selected out of 3 people. So in total, 3 people selected to represent the UK in Vladivostok, Russia. So Russia was okay then. So we had 3 people gone from UK, and then we had a network of 200 more young professionals, 70 countries coming to Vladivostok, and we had good networks. Since then, I have actually gone into BSI, which is a British Standard Institute. So I'm part of the technical committee for them to make the standards on measurement and control devices. Now, that has given me more insight into the theoretical part or learning more stuff. You utilize your skill as an end user, what you have done. However, you listen to people. I'm surrounded by very experienced, so R&D director from a company, the SMEs, they will be sitting on the technical committee from Germany, China, Japan, US, Canada, and you listen to them and you contribute as well based on your experience. I think that's when it helps more off of that learning, which you may not get from your books or from your industry where you're working on. So I think that also helped me in getting more information about knowledge about what's happening in the wider industry.
Right. As a takeaway, I think it's more of adapting to the situation, and also on the job training is key.
Yeah.
You know, listening to the experience.
Yeah, you're right. I mean, put yourself out there. That's what I would suggest. If you're doing a job, it's all good, but try to see what other opportunities within the job. How can you improve? I always ask my group to have one objective, which is towards the innovation. That everything is operational, which is good. But what can we do to actually improve the operation, the efficiency of the system they're actually working towards? And that makes us think out of the box rather than just doing our day-to-day job. We think how we can actually improve things. And that's the learning that we actually enjoy, because that stimulates our brain as well.
Yeah, very, very well said. Thanks so much for that, Navdeep. And I think we have another question from Ahmed. Automotive working environment and nuclear working environment, a question I think gets asked to me as well several times. The question itself is okay, so both this environment, I assume, is different. What type of training studies one should consider before moving to nuclear environment?
Very good question, Ahmed. I'm glad that you picked it. I must have missed it when I was saying. So that's the beauty of becoming an engineer, or especially an electronics engineer. Now, you use electronics. Electronics, you know how it's going to work. Now, where is it going to be used? That's different. Now, it's used to be pharmaceutical. It can be used in hydraulics, where I used to work in automotive, and it can be worked in the nuclear environment. Electronics behavior is not going to change, and if you are the electronics engineer, you know how it's going to behave, and you can adapt it to based on different environment. Now, so that's so when I was automotive, it was mainly hydraulics, but my logics from the electronics, from the control instrumentation, they were same. So I knew, but I had to learn a bit of hydraulics. And where I'm working now in nuclear, it's all physics. I'm surrounded by physicists, and you do listen to them. I mean, I had to take my books out just to get back into that study, what exactly I've done in the university, because we haven't picked that up since. But now listening to them, they go into that degree of understanding that it's amazing to be part of that, because like I said, you need something to stimulate your brain. And I think this job has actually given me that since last 3 years or so. In terms of training, because UKAEA, or the Atomic Energy Authority, when they recruited me, they knew that my background has been control instrumentation, but in different environments. So every industry, they do have the induction program, some sort of program to get you familiarized with the environment, with machine that we're working on. I had same in here. So I got training as a machine engineer in charge. So this is the person who will be operating a machine, working with the session leaders, which are the physicists, working with scientific coordinators who will be telling that this is the next pole that we want. And all the power supplies, all the data acquisition team. So they will be collating information from there, handshaking the signals with them and saying, yes, I'm happy to run the machine now for that post. So that training, as I say, I think it's 20 odd courses that I had to do. And then I had to do the shadowing of the trained MEIC, engineering in charge. And then you have that, you get the confidence, you get the understanding of how the machine operates. So yes, and they all welcomed. It's not that they only want the people from fusion, because they're not much fusion, as you know, even if nuclear fission, yes, they will be helpful because they have the understanding. However, they do work differently. The safety sides is same. So we are actually copying the safety as if this happens in nuclear fission, because it gives us that blanket that we don't have to reinvent something. But in terms of the operation, in terms of the technical stuff, you learn that when you're there, they will give you the information or the training when you're on the job. So, however, you need to be strong in your electronics, in your technical stuff, that you can do your job once you know how it's going to be used for. Yeah, that's what I would say.
No, great advice, actually. Because I think it's a question that gets asked to me as well, several times, because myself was in an automotive and then jumped into nuclear. What sort of training have you taken, or what you need to study? But excuse me, you being in a different sector than what I work in, it's quite nice to understand now that I can see what I need to do in order to get to where you are. But absolutely brilliant. Well said. All right. I think we are right about time. Navdeep, thank you so much for your time this half an hour. We'll move on to Swetha. And at the end of it, I think we'll give a couple more minutes for our audiences, if at all there's any questions to ask. And Navdeep, you can also ask Swetha any questions if you have after her time. So with not much further ado, I would like to invite Swetha Thayalsamy for her presentation and onto the stage. Off to you, Swetha.
Yeah, sure. Let me just share my screen. Okay, yeah. So hello, my name is Swetha Thayalsamy, and I'm a hardware testing engineer at Sky. So during this presentation, I will be discussing what I do as a hardware engineer and how I got there. So yeah, I hope you enjoy. Yeah, okay, so I went to an all-girls Catholic school, and I also come from an all-girls household. And so education was always emphasized, but being an engineer was considered kind of a boy's job. But like at school, it was because of my DT teacher who kind of introduced us to the Crest Awards that I really got into engineering. And we formed this group called the Sustainables, and we had to design a sustainable home for Bangladesh. And so we researched loads of materials to use and building techniques that we could use and implement in Bangladesh that would essentially combat against any harsh weather conditions. And yeah, so I think we ended up presenting to David Cameron, which was really cool. And so, yeah, I think at this point I decided, yeah, I want to do engineering, but I wasn't really sure what I wanted to do it in. And so I was lucky enough to get into Warwick. And yeah, so I did a 2-year general course. And it was only during my semiconductor lecture that I realized that, you know what, this is actually really cool. Electronics is really interesting, and something so small could power so much. And so, yeah, I decided that I wanted to study electrical and electronics engineering. And so, yeah, so I think after my dissertation, I realized I kind of needed a break from education. And so I decided to take a placement year. And I was again fortunate enough to get a placement at Leonardo, which is an aerospace and defense and electronics company. And yeah, so I worked with loads of really exciting and like interesting engineers who are all in hardware. And I think this is the first time I actually realized what hardware engineering was. And I was very much out of my depth now looking back. But I worked with like really cool people and I did a lot of testing there. And I think at that point I decided actually over electrical engineering, electronics kind of suits me a lot more. And yeah, I didn't actually go back to finish my master's. I ended up looking for another job in hardware engineering. And again, I was very lucky to get a job so quickly at Sky. And so I finished my placement year early and I ended up at Sky as a hardware testing engineer. And yes, I've been there for a year and a bit now and it's been really good. So yeah. Yeah, okay, so before I go on about what hardware engineering actually is, I thought it would be a really good idea to explain what Sky is. And so I'm sure everyone's heard of Sky, but Sky are Europe's largest broadcasting and media company, and they have over 32,000 employees worldwide. We have offices all across Europe, all across the UK, and we are now expanding to America, which is really exciting. And being part of it is really cool as well. As market innovators, we are constantly launching new and new products. And by 2021, I think we got to 2 million customers. We have a range of graduate schemes. And I think there's a lot of different varied technology-based graduate schemes. And we have a high graduate satisfaction grade of 8.8 out of 10. So yeah, now this is what I do as a hardware testing engineer. So I've broken it down to like 6 parts. So the first thing is probably I run around a lot, which is really good for my steps. But majority of my time I'm working with the hardware design team. And essentially what they do is they produce a design. It's then printed on a PCB board and then it comes to me and my team and we qualify and test the design to ensure that it actually does work and it does meet all the requirements. And so a lot of my job revolves around problem solving and conducting investigations, especially when the issue is just really strange. Like for example, a couple of weeks back, there was a frequency spike that just shouldn't have existed, but it was there. And so it was my job to basically take it to the test house and run as many tests as I could within a day and determine where that frequency spike was coming from. I found the issue and then I just went back to my team and then we discuss it as a hardware team. And then find a solution for it. So again, a lot of my time is spent liaising with the hardware design team and the software team because they're the guys that produce the code that gets put onto my boards. So yeah, it's a lot of talking basically. Another important part of my job is compliance, and compliance is basically like a checklist. It's like internal and external regulations that are created by external engineering bodies, and if we don't pass these, we can't put our products out into the market. And so we kind of have to do this. And so my team and I basically break down compliance and take sections each. So it's not such a big task, but yeah, no, it's something that is really cool too. So I'm not sure if you guys know, but Sky are bringing out a smart camera, which when paired with Sky Glass, which is the TV that we just brought out, you can work and play and talk to your friends. And so I was on that project for a couple of weeks. And so the smart camera, I've never worked with a camera module before. And so a lot of my tasks as an engineer, as a hardware testing engineer, is learning, and that's literally it. I just have to learn loads of things. And so I think I got asked to find a way to determine the performance of the camera module, and I don't know how to do it. So it was a lot of work trying to figure out which characteristics to think of and to test and how to best do it. And so yeah, so I basically automated the process, and yeah, I was able to automate it using Python and control all the supporting equipment and also the camera itself. And it basically just frees up my time, meaning that I can work on other things whilst this test is running. So yeah, and automation is really fun because I get to code, which is great. And yeah, so the other thing about being a hardware engineer, I think, is as the number of responsibilities increase, you end up talking to loads of different people all across the business and not just from the hardware and software department. And you talk to third-party companies as well. And so, yeah, that's really quite cool as well. So yeah, so to basically explain it a bit further, this is the timeline of a product, and I'm going to explain where my role kind of fits in. So there's initial discussions where the project requirements are outlined, and here we talk about the cost of the product, which chipsets we want to use, and like what components we want to use, and yeah, we basically break it down, and then we move on to the development and testing stage, and this is usually R&D, but as time goes on, it becomes the actual product. And so here the hardware and software counterparts just work with each other, and I'm basically doing I'm working at this point, and yeah, and so yeah, like all the engineering roles are determined, and I'm able to go to who I need to go to if I have any questions. And then eventually at the end of this stage, we have a final product and we're able to launch, which is like the most exciting part. And so, yeah, the entire product timeline takes about a whole year, a year and a half. It just depends on how quickly they want to put it out into the market. Yeah, and yeah, so I've had like loads of highlights at Sky actually. So I think the most important one and my favorite one is becoming hardware test lead on a current project that I'm working on right now. I've had loads of opportunities to work on some really interesting projects, ones that have taken me out of the country to Paris, which was great. And as a result, I've met some really amazing engineers who've helped break things down for me and helped explain things to me when I've been super confused. And yeah, so this has all given me the opportunity to like develop and create my own test methods, and given me the confidence to take on being a hardware test lead. So yeah. Yeah, and over the last year and a bit, I've had a couple of reflections, and I think my favorite, most important one is probably continuous development. Like there's always something to learn, and there's always something to improve and become more efficient. And especially as a test engineer, efficiency is key and speed is key as well. And so I think always learning and developing is something that's important, especially when the tasks get harder and harder. And so you have the skills of jumping into something, like you can just carry that forward. Having an encouraging environment is something that I really appreciate. I have people within Sky and then people outside of Sky who I can go to and ask for advice whenever I need them, and they're always there. And especially when I don't know what to do next, I think I get very anxious about that. And so having people to go to is very helpful, and just knowing like the right opportunity will come is something that I just hold on to basically. And yeah, I think that's it. So yeah, if you have any questions, do let me know. But yeah.
Thank you so very much, Swetha. That was indeed really nice to hearing of where you started off with and where you got to. Really, really wonderful presentation and talk. In fact, thank you so very much for that. I think I'll start off by asking a question which I had while you were going through your presentation, which was with regards to hardware and coding. So you actually took us through two separate different, I would say, environments. You being a hardware test engineer and you like coding. So coming out of the university or coming out of studies, what was that you wanted to actually do? Was it the just manufacturing the hardware bit side of it, or was it the coding side of it that you really wanted to concentrate on?
I think, again, it was like the mix between the two. I didn't want to go into full coding or software engineering, but and I like the design aspect of hardware engineering and improving something. And so finding a balance, I think that's what my job has been. So yeah, I'd say like the merging of two is where I'm at right now. I think I will stay there for the foreseeable future, if that makes sense. Yeah. Right.
What is that one advice that you would give to our audiences who are school leavers, who are looking for the next sort of step? Is it the right start as going to for an placement year and then moving on to a job, or is it directly going to a job is what that one thing that you would advise?
I think experience is key. Without my placement year, I don't think I would be a hardware engineer. I'm not sure where I would have been, but definitely probably not hardware engineering, because I didn't know it was something that I could do. And only through my placement year did I find out that it was something I enjoyed. I think it depends on the person. If you're like, if you know what you want to go and what you want to do, then yeah, that makes sense. But I definitely didn't. And so taking that time to think about things and like actually figure stuff out was very helpful for me.
Was it hard to actually get into a placement year, the application, or how does it actually work? Is it just through applications or through interviews? What was the process that took you through?
Yeah, so I remember just waiting for my email to ping, but so yeah, no, I think it was quite a long process, but I waited a couple of months to get a placement year, and yeah, I think it does answer your question. I'm not sure.
Is it, I mean,
Yeah.
since our audiences are school leavers,
Yes.
what is the process like? Is it really difficult to get into one, or what is that you need to go through? What are the hurdles that you need to jump in order to get to the placement year, sort of, getting yourself placed in such an industry?
Yeah, so it's like applying for a job. So there's like different sites that you can use, and then you basically just look at what you want. Again, you have to write a CV for the particular job, and then interviews. I went to a couple, and then you do, I forgot what it's called, but like you do rounds of interviews. So there's loads of people, and they'll put you in teams, and then you just have to basically shine and do what you can. But yeah, I think I got lucky. Yeah, definitely. So, yeah.
No, I'm pretty sure you did really shine those sessions. Right. So we have another question from our audience. Joe Ryder has asked, can you tell me how you test that a product follows a certain compliance?
Yeah. So as I mentioned, compliance, there's like regulations. So there's actually industry standards that you can like Google and check. And a lot of those industry standards have their own specified test method, and it's something that you kind of should follow. Well, you're supposed to follow. And so, yeah, so basically you replicate your testing to fit that. A lot of compliance, if you do it in-house, you can't just pass with in-house testing. You have to take it to external test labs who will basically run safety tests, radio tests, emission tests, stuff like that, which basically make sure that your product isn't harmful for the people who are going to basically put it in their house. If you pass those tests, then yeah, you're good to go. Again, compliance is something that goes throughout the whole project, and every like iteration of design is something that you would do compliance again and again. And regularly you end up failing it, but at the end of it, you will pass if you like take on their suggestions. Yeah.
Right, great stuff. Within Sky, you did mention that you did get chance to travel a lot, especially France and Paris. So is that one thing that you would also look into when you're applying jobs? Whether there is a lot of travel involved, or what is the sort of mentality you've got in there? What is your advice?
I actually didn't know you could travel as an engineer, so I think it was weird that I got offered it, but yeah, no, I was really excited. I was like, yeah, whatever. I don't even know where I'm going, but okay, let's go. So yeah, I think it was really good to go. And we went to go talk to like a third-party company. And so if your company does work with other industry, like other people in other countries, then yeah, it's definitely something to look into, especially if that's what you want to do as part of your job. Yeah,
I'm certain that there will be a lot of hardware test engineers, within your space. Is it a tight competition that you see, or what is the market like, for being a hardware test engineer itself? Is it something that is readily available, or where do you see that particular role in?
Competition wise, I within my team, they've recently hired a lot of younger people, and so all of us, I think, want the opportunity to shine, obviously. But again, as I mentioned, like the right one will come for you, and I think taking the time to like learn your skills and learn your actually make sure that you've got the foundation is more important than like just going straight into it. And yeah, I would say, like, I think there's a general engineering thing where like people are very competitive. But I think, staying on top of that and not letting it get to you is important, because it can. So yeah.
Very, very well. So thank you so much, Swetha, for that. I think it's true, isn't it? You need to have a really good foundation in order to go to the next stage of where you are. Yes, there are on-the-job trainings as well, but having a really good theoretical knowledge, a bit of a practical knowledge helps you throughout the journey. Very, very well said. Thank you so much for that. Right, I think we have another question, probably for both of you. If not, Deep, you could kindly join us as well. Swetha, you could answer this first. What are your future plans and where to next?
My future plans, I think I want to, so I'm hardware test lead for my new project. So that's something I want to kind of continue. I also would like to improve my hardware design skills on top of that. I think one day in the future, I would like to go into like sustainable tech, which is something that I'm looking forward to, I hope. So yeah, that's what I'd say for me.
Thank you, Swetha. I think that actually joins to Navdeep being a sustainable comment in there.
Yeah.
What is your future plans and where to next, Navdeep?
Yeah, think my personal interest has actually gone more into artificial intelligence. So I'm trying to learn more about it and see how we can actually implement that into what we do. Because machine learning and AI, I think these are the future. But how we can bridge that existing technology, existing systems, and utilize AI into it. That's my next thing. So I was, and listening to Swetha, I think that's very impressive. I can only add to one of the questions, to the answer that Swetha did, that to go as engineer, and at certain point you will have a choice. You can either go into as a subject matter expert, stick to your technical, or you may go into more of line management. I chose more of the line management and looking into wider field. And as part of that, I'd mentioned the chartered engineers was one step. If you do like traveling, if you do like networking, I think engineering is the way. I'm not saying the other fields are not. However, do not feel that if you go into engineering, then you can only go with the technical side. It opens those to the wider industry and also wider audience, you can say. So only this year. So I'm in chair of the Institute of Management Control, the Special Interest Group, SIG. Now that's networking with like-minded, very experienced people from wider industry working in the same field, which is control instrumentation, measurement and control. So it's about where you want to take your career. It's all in your hand. Do what you love, how you love, and then I think you will find the ways to achieve your dreams. That's what I will say.
Well said. Open pool, isn't it? You can, it's open opportunities. You can drive yourself into whichever path you really wanted to. And I think the points actually mentioned by Swetha and Navdeep is I think one of the ways actually to drive towards where you want to get to. Owain has asked us a question. I think this is more towards Swetha, but I think with regards to testing, I'm pretty sure Navdeep you would have gone through as well, but I would like to ask Swetha to start with. You mentioned you coded your automated testing process. Is there any general transferable skills you think universities don't teach you, but think someone would benefit from? Example, a software or programming language?
Yeah, so I would say, so for my automation, I usually use Python, which I really like. But again, it depends on what kind of automation you're doing. So at university, I use LabVIEW, which again, I use at work as well when I'm trying to control a lot of different equipment. So yeah, it's one of those things like there are things at university that will help and things that don't. But yeah, I feel like I've learned a lot on the job, more than maybe what I would have done confidently at uni. That was just because I just didn't have the confidence to try things out. But now I have the time and I have the opportunity to do so. And it's okay to mess up, so which I do. So yeah.
Yeah, I think that's a follow-up question as well. How much trial and error was involved in that learning, what you needed to aim for the best performance?
Yeah.
Was there a number that you can give? I don't think there's a number you could give us.
Yeah. So I think So for example, there are certain tests that I repeat again and again. And the first time I do it in a specific, very manual way. And then the second time I've learned from that and I'm going, okay, wait, how can I be more free? So I will try and find a way to do it. And so basically the more I do things, the more efficient I get, I hope. And so that's what I would say. And also like even just my manager said this to me, he was like, why don't you just plan things out? And so I tend to like just sit there and go, okay, so how do I do this? Like what is the best way to approach this test? And I like tend to draw things out for my own sake. So yeah, I think I've just figured out the best way to approach a task for my own benefit. So
Right.
yeah, so I would say.
Thank you, Swetha. Navdeep, on to you. I think you mentioned artificial intelligence is where you wanted to get to, which will definitely involve a lot of automated testing. I would think. In that case, is there any transferable skills that you have had? Probably not in the university because that was a long time ago, but not that long time ago. But in your work experiences, is there something that you can actually use that for the future? What do you think?
So I've been listening to Swetha. I think I agree with exactly what Swetha said. My experience has been in that, like the name said, it's a language, and depending on where you are, environment, you can learn another language. But whichever language you pick, it's the logic behind it that you need to understand. So as long as you are good in understanding those logics, you can learn another language and apply the same logic to it. So I will say, have it try, pick which one you like, and then go for it. It will be transferable as long as you understand the logics behind it, and always transfer it to any other environment.
Great stuff. Great answer. Thanks. Next, Navdeep. I think to close the session, I would like to ask both our young professional speakers today, what is that one advice you would give to our audiences in terms of what profession they have to choose, or what is that, what is that you had as your experiences to choose what you've achieved up until now? What is that one advice that you would give? If I could start with you, Swetha.
Yeah, so I think when choosing what I wanted to do, I needed just to experience different things and like figure out what was available to me and what skills I had that would work in certain industries and what I actually enjoy. If it's not something I would enjoy, then I don't think I would do it. And hardware is something I enjoy. And so, yeah, just thinking about what you want and then taking the time. There's no rush, I think. But it feels like there's a rush, but there's not. So yeah, that's what I'd say. Well
said. Yeah, no rush, guys. Take your time. You will fall into where you belong to. Navdeep, that one advice that you would be willing to give to our audiences.
Yeah. Advice based on my experience. I mean, it's a very generic advice. Follow your dream. That's the strong how I feel that. The reason I'm saying is that because when I was a kid, I had an uncle and he used to work in a power station and always wanted to be like him. And that was my dream. And then eventually everything got into right place. And I actually ended up working where he used to work in his place. So in a power station. So that was my dream come true, and then carried on since then. So whatever is you like, work hard and follow your dream. That's all I will say. It can be electronics. If it is, that's very good. But even if it's not electronics, do what you like the most.
Thank you so much, Navdeep. Meet the engineers, our electronic engineers talk. So this was the Volume 2 Series 4. So I would like to end the session with a couple of announcements. 23rd June 2022, it is the International Women in Engineering Day. Follow us on social media. There are a couple of surprises you could see on our social media pages: Twitter, Instagram, LinkedIn, Facebook. And finally, thank you very much, our speakers, once again, Swetha and Navdeep, for joining us today. Thank you, audience. for ever being enthusiastic, asking questions, appreciating us in each and every session. So we do request your feedback. As at the end of it, we will be sending it via email. This event was conducted to you by the IET London Young Professionals network. We do impactful events such as this. We do personal development. We have a teamwork, a big teamwork behind this. I have my co-host behind the scene, who's Dilani. Thank you, Dilani, for supporting this event. Wonderful as always. And we do also have a fun social events. So join us to join our team. These are our volunteer emails, Toby Lushan, Dilani, and myself, Sham. And yes, please do follow us on social media. You will be really happy to join us and find what's going around in the IET London Young Professionals. So I thank you once again, speakers. Thank you, audiences. Have a very wonderful rest of the evening. Until the next time. I'm Shyam signing off. Thank you so much, guys.
Thank you for having us.
Thank you.